Alright, I'm going to try to get one video done here. So this one's all about angles of triangles and proving triangles congruent. So our warm-up here, first we have our triangle given to us RST. We don't know much about it aside from some angles and some expressions for two of the sides. But we do know that one of the angles is 102, that's angle R. And since that angle is 102, that means it is an obtuse angle, which makes this whole triangle obtuse. But we also know that the other two angles are both 39. And because we know that, we can now say that it is an isosceles triangle as well. So it's an obtuse isosceles. Next we need to find y, and again it tells us that it's an isosceles triangle. So what we are going to do, since it's isosceles, we can take these two sides and set them equal to each other. So that's 3 times 2y minus 2 equal to 5y plus 6. 3 times 2y, 6y. 3 times negative 2, negative 6, equal to 5y plus 6. So we need to subtract 5y from both sides. Which leaves us with a one single y left, minus 6 equal to 6. We add 6 to both sides. And 6 plus 6 is 12. So that's what y is. For number 3, we need to find x if triangle ABC is an equilateral triangle. So we have 3 sides given to us as expressions. We can use any of those 3 sides, whichever 2 we choose to use. I'm going to use the 6x plus 5 side. And I'm going to set that equal to the 4x plus 13. I'm going to subtract 4x from both sides. So we now have 2x plus 5 equal to 13. I'm going to subtract 5 from both sides. 13 minus 5 is going to get us 8. So 2x equals to 8. You divide by 2 on both sides. X is equal to 4. So we did some vocab this day, or I think we finished it up. So out of the vocab words, auxiliary line, exterior angle, remote interior angles, flow proof, corollary, congruent polygons, and corresponding parts are what we're looking at today. The first one is the triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180. So the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. So knowing that, we need to find angle 1 and angle 2 within this figure. Angle 1 is fairly quick because we know now that the sum of the angles is equal to 180. So the measure of angle 1 is equal to 180 minus the sum of the other two angles, 74 and 43. So we sum those together and we end up getting 117. And 180 minus 117 gets us the measure of angle 1 to be 63. Now, for angle 2, this is kind of cool here, because if you remember back to the last unit, we had vertical angles being congruent, and angle 1 and angle 2 are vertical angles. So that means that if angle 1 is 63, angle 2 is also 63, because they are vertical angles. So now we just have to find the measure of angle 3. We now know 2 out of 3 of the angles for this one, for this triangle. And angle 3 is the one we don't know. So same process we had for the measure of angle 1. 180 minus the sum of the other two angles. 63 plus 79. We add those up, and that equals 142. So the measure of angle 3 is equal to 180 minus 142, which comes out to be 38 degrees. There's the 3 missing angles we have. The exterior angle theorem. So here, the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. So remote interior angles are the angles on the opposite side from where that exterior angle is. So for here, angle A and angle B are the remote interior angles. You add those up, their measurements up, and you get the measurement of angle 1, the exterior angle. So here we are given a triangle with an exterior angle, 2x minus 48, and we're also given some angles inside. Those are the remote interior angles. So x plus 32 is our remote interior angle sum, and that needs to equal what's on the outside, the 2x minus 48. So 2x minus 48 is equal to x plus 32, and now we just need to solve for x. And then once we get that, we can plug it into either half of this equation. So first thing we're going to do is subtract an x from both sides. So 2x minus 1x is just x minus 48 equal to 32. And now we just need to add 48 to both sides to get what x is. So x comes out to be 80. So now we need to plug it back in. And for me, I think the right side of our original equation, 2x minus 48 equal to x plus 32, since they're equal, we can use either one, even though we're trying to find the measure of angle FLW, which is where the 2x minus 48 is. But since we know that they're congruent, we can just, or they're equal, we can just do either side. So the measure of angle FLW is equal to x plus 32, which is equal to 80 plus 32, or 112. Okay, triangle angle sum corollaries. I didn't make you guys write these down during the notes because they're kind of common knowledge. They're pretty kind of commonsensical. So if you read them, you should be able to figure that out, and it makes sense. So the acute angles of a right triangle are complementary. Remember, complementary, as long as you know your vocab words, these are common sense. Complementary means that 2 angles add to be 90. So if you have a right triangle, remember the sum of all the angles of a triangle add to be 180. So one of those angles is a 90-degree angle because it's a right triangle. Take that away, 180 minus 90 is 90. So that means the other 2 angles have to add to be 90 because that's what's left over, which makes them complementary. The second one, there can be at most one right or obtuse angle in a triangle. Again, we know the sum of all the angles needs to be 180. If one of them is 90, there's only 90 left over for the other 2, so they have to be less than 90. Same with obtuse, because if, again, one of the angles is, say, 103, that means there's 77 degrees left between the other 2 angles. Neither one of them is going to make it over 90, so they can't have another obtuse or another right angle at all. That's what I kind of mean by them being common sense. So here we need to find the measure of each numbered angle once again. But now we're going to use all of our things we've looked at together. So we're going to look at the exterior angle theorem combined with the triangle angle sum theorem, as well as knowing that vertical angles are congruent, and knowing that linear angle or linear pairs are supplementary. So all those things combined into one for this problem. So for angle 1, it's an exterior angle, and the remote interior angles are the 32 and 38 in the top triangle there. So we just have to add those up. And 32 plus 38 is just 70. So I'm going to write them in the picture so you know what they are. Now, knowing that that's 70 means that also the angle across from it is 70. So that's going to help us out later. But we also know angle 2 is a linear pair with both of these angles. So that means for the measure of angle 2, remember linear pairs are supplementary. So that means if we take 180 and subtract the 70 that we just came up with, we'll get what the measure of angle 2 is. And that is 110. So again, I'm going to write these in here, 110. And that means the vertical angle across from it is also 110. Okay, angle 3. Angle 3 has we now have the other two angles inside of angle 3, or the triangle with angle 3 in it. So now we just have to do 180 minus 70 plus 64. Or 180 minus 134. And this comes out to be 46. Okay, so now angle 4 is part of that line, right? The line with angle 3 and the 32-degree angle. So that means 180 minus angle 3, which we just found was 46, plus 32 will get us what's left over of the 180 that that makes. So 46 plus 32, 78, and 180 minus 78 is 102. So our last angle, angle 5, very similar problem to angle 3. So we're going to take the measure of angle 5 is going to be 180 minus the 102 we just got, plus 41 that's given to us on the other side of that triangle. (102) plus 41 is 143, and 180 minus 143 is 37. So angle 5 is 37, angle 4 is 102, angle 3 is 46, angle 2 is 110, and angle 1 is 70. Alright, I had to cut that announcement off there. Nobody needs to listen to that, unless you're getting on the late bus to go home. Alright, so definition of congruent polygons. So if two polygons are congruent, if and only if their corresponding parts are congruent. So in the figure here, we need to find the values of x and y. So we know they are congruent, it tells us they are. And since we know they are congruent, that means that their corresponding parts are the same. So if ti there is 7.5 and ti matches up with gn, then x minus 2y is equal to 7.5. And same with angle P. Angle P matches up with angle O. Angle O is 6y minus 14. Angle P is 40. So all we have to do is set those equal to each other and find y, and then we'll use y to find x. So 6y minus 14 is equal to 40. We're going to add 14 to both sides. So we're left with 6y on the left equal to 40 plus 14 is 54. And we divide by 6 on both sides. And 54 divided by 6 is 9. So there's y. So now we need to find x. And we know that x minus 2y is equal to 7.5, as I mentioned earlier. So we need to plug in y. So x minus 2 times 9 is equal to 7.5. Two times 9 is 18. Now all you have to do is add 18 to both sides. And 7.5 plus 18 is 25.5. Okay, so now we have the third angles theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle are congruent. Makes sense, right? We know now that the sum of all the angles of a triangle is 180. So, if the sum of all of them is 180, you have two pairs that match up with two different triangles. Then the third one has to be the same because the difference between 180 and those two is going to be the same for both triangles. That, however, does not mean that the triangles are congruent. Keep that in mind. Angles do not have to be all the same, and the sides also will then be the same. We'll get more into that later on. Properties of triangle congruence, same properties we've been looking at. Reflexive property, just repeating the same thing. Symmetric property, just reverses it. The transitive property gets rid of the middleman. So triangle ABC is congruent to triangle EFG. Triangle EFG is congruent to triangle JKL. Then triangle ABC is congruent to triangle JKL. Here's your exit ticket. You're going to need to fill in the blank. What goes in that blank to prove this?